and gentlemen, on behalf of the Association of Geospatial Industries, I warmly welcome you all to the India Geospatial Leadership Summit 2024. This summit brings together senior decision makers, public and enterprise users, industry professionals, and researchers across domains working with and towards geospatial technologies, which is poised to irrevocably transform India's development trajectory. Today's conference theme, Geospatial Technologies Accelerating National Development, touches upon the critical aspect of the transformative potential of the technology in governance, decision-making, and mission mode progress of the nation. I thank our government partner, Survey of India, Platinum sponsor Hexagon, Gold sponsor Esri India, sponsors NeoGeo Info Technologies, Kesova, and MapMy India, and our partners for the summit, IIT Kanpur, Geospatial World, GISE Hub IIT Bombay, Indian Space Association, National Institute of Advanced Studies, the Open Geospatial Consortium, SIA India, and T-Hub for their support to the summit. With this, may I now invite on stage for the special address for the opening session of the summit, Dr. Mrutyunjay Mohapatra, Director General of Meteorology, IMD. Sir.
Namaskar, good morning to all of you. At the outset, I congratulate the organizers for this noble initiative on utilization of GIS for national development. I also express my deep gratitude for inviting me to be part of this program. As all of us know that India Meteorological Department deals with geospatial technology. So therefore, when I got an opportunity to be associated at any time, I used to be there. As I understand, we can learn a lot from all of you, and we can work together also, and we can improve the GIS applications in all sectors. When we consider the national development, yes, the geospatial technology can play a crucial role in all aspects. Be it any socio-economic sector, you can find that nowadays there is application of geospatial informations. At the same time, the government has become very supportive, and over the years there has been reforms with respect to the data policy. Geospatial policy is in place, which has also opened up the avenues for the students, researchers, academia, and industries to utilize this data. At the same time, there has been development of the cross-cutting technologies like AIML, which again is combined with GIS applications to have various types of data analytics and infographics, and also the development of tools and technologies. So I feel in India today is a golden opportunity to utilize all these technologies in a blended form and hence serve the society. We can see the potential how it can transform the economic conditions of the country. If you just look at during past 10 years, you will find that there has been applications in an accelerated manner. For example, if I talk about India Meteorological Department, we have been in the business in the form of the observations in all spatial dimensions and temporal dimensions. So be it very simple observations like rain or temperature, pressure, and otherwise the spatial data from the Indian national satellites and many other microwave polar orbiting satellites. But all these were being utilized as you can say a standalone system without any georeferencing for the common man or for the users in the country. But in the last 5 years, what we have done actually with the help of Survey of India, with the help of many other partners like Indian Space Organizations, state remote sensing agencies, and India Meteorological Department, we have come up with georeferencing the data. So at present you will find that all the data in India Meteorological Department are geo-referenced and also available to the public. There is a data portal where people can access the data, utilize the data, and develop the products. So not only that, this data policy, which also has been reformed by various organizations in the country, provides the avenue for the beginners, the startups, and the existing developed and developing industries. It is helping to access the data, and from India Meteorological Department, I will tell you, we can provide all the data, whatever is needed, free, if it is meant for socio-economic development of the country and development of any startup industries or development of any tools and technologies. So I take this opportunity to request all of you, please look at India Meteorological Department, its potential, which has been demonstrated during the last 5 to 10 years, how accurately it can predict the various types of severe weather events, utilizing the geospatial industries, how the granular informations are being provided to the people and the disaster managers and the various stakeholders. But whatever we have achieved so far is not sufficient if you consider the country as a whole. We have the geospatial applications visibly available or visibly applicable with respect to tropical cyclones. We have the granular information at the village level to assess the hazard, impact, vulnerability, exposures, and the risk. It is being utilized. As a result, the loss of lives and loss of properties has been reduced to some extent, and cyclone Biparjoy was a very good event. Similarly, there has been applications with respect to the heat waves and cold waves. We have been able to georeference all types of geophysical hazards, meteorological hazards, secondary hazards, geospatial database, and also the socio-economic database. For example, if the Indian Railways wants to know which sector of the railways will be affected by the heat wave today, that information is available, and accordingly the action can be taken by them. Earlier, it was a subjective assessment, and it was not possible to indicate the potential of the threat due to any particular severe weather on a national highway or the Indian Railways. So this is possible because of the geospatial technology, where we are able to compare, comprehend, and analyze the various types of information in a decision support system, which is geospatial database and which is georeferenced. Similarly, there has been other success stories like heavy rainfall and the thunderstorms, where also all the data are being georeferenced. But what I find that there are certain issues with respect to this geospatial technology or applications. The first and foremost issue is that the availability and accessibility of the data. There are many data sources in various parts of the country where data are in the manual form or the analog form, and data are not digital, data are not georeferenced in digital format, and hence it cannot be utilized. So there is a good opportunity to convert and utilize this database. This is available from various government agencies and also non-government agencies, especially state government. If you just go ahead, you will find that there are a lot of data in the hard printed form, but it is not available for use because it is not digitized. The second issue comes up, the whatever existing data we have got, it does not have sometimes the quality checked. The quality assurance is very much essential while you go for geospatial technology. Unless it is quality assured, it may create problem when you overlay the data. Say for example, if you have some kind of base map error in satellite, for example I am talking about, by say about 10 kilometers, and a thunderstorm is occurring in a particular place, a thunderstorm has a size of about say 1 to 10 kilometers. So you may miss the occurrence of thunderstorm by the satellite. Similarly is the radar. It says resolution of 350 meters. So if you got 3 to 4 pixels out, then you will miss the particular event. So therefore, it is very much essential to assure quality of the data time to time, which are being georeferenced and being utilized for all types of applications for socio-economic development. There is another issue what I find, that the resolution of the data. The geospatial data, whatever is available in the country, does not have the desired resolution when you go for some specific applications. So I will talk about, for example, the hydrometeorological disasters. If you are going for, so for example, large scale floods, or you are going for these tropical cyclones, so whatever resolution you have, that may be sufficient. But when you go for the small scale weather events like, say, lightning or thunderstorms or squall or hailstorms, in such cases the resolution data is not sufficient as far as detection of the events, etc. But when you go for again the socioeconomic database, resolution is quite poor again. When you go to geospatial database, you will find that the elevation, digital elevation, for example, is not of expected a resolution which can be utilized. For example, if you are giving the information about the flood depth, if the digital elevation is not of high resolution, then you may not be able to find out so much accurate flood depth over a particular watershed. But still then we have gone through. Now you can find out there are guidance about the flash flood guidance, urban flood guidance, and also the riverine flood guidance. So I am just highlighting these limitations with respect to the resolution problem and the accuracy problem, so that while utilizing the data, we can take note of it, and the source provider, the data source provider also should be aware of that, and they should meet the requirement of the users. So another area where we have to move ahead, that is the applications. So there is enough scope for GIS applications, and there is the scope to improve the socio-economic development. Very limited sectors are being utilized with the geospatial applications because of all these issues, and also because of perhaps the lack of understanding by the users and lack of understanding by the service providers. So there is a need for some kind of integration, an integrated process and a mechanism where the users and service providers can work together. So for example, this fora, whatever is meeting today, may be a good occasion where the people can understand, can utilize, and talk to each other to understand, and finally can have an approach. So what we feel that it is a cross-cutting technology, and it is a multi-institutional area. So any organization who is likely to develop the geospatial technology or apply the geospatial technology has to work with other organizations together, and hence can have the real benefit from the geospatial applications. So if you ask me whether we have achieved a lot, for example, I will talk about India Meteorological Department. Yes, there has been significant improvement with respect to disaster risk reduction in the country. The early warning has improved by about 50% in the past 5 years as compared to previous 5 years. And geospatial application has helped us to have the better services, to have the better analysis, the better forecast, and better accuracy, and the service delivery. So by that, if you just look at, there has been reduction not only in the loss of lives, but also has been reduction in properties. So while doing so, what we have done actually, we have gone for the impact-based forecast. And when you go for the impact-based forecast, there is the need for the geospatial database. Without geospatial database, you cannot go for impact-based forecast. We gave the impact-based forecast, even if we say the first impact-based forecast was provided in 1865. So there at the time we told that Calcutta port will be affected by the cyclones. We gave the signals like day signal, night signal, etc. That was the first impact-based forecast. But that was the qualitative, and gradually it improved, and we came up with specific impact in various sectors. And nowadays we are able to provide the GIS-based dynamic impact-based information for various types of severe weather. But we can go together, and we can work together. We have got a lot of data. From 1901 onwards, we have got digital data about the ground-based truth. We have got the space data, that is the satellite data from 1983. And we have got the radar data, naval radars long back from 1974, and digital data of radar from 2002 onwards. And also the number of source also increased. Now we have got 39 radars. Starting in 2002, only one deployed radar in Chennai. Now we have got 39 deployed radars. The real-time data are also available. Archive data are also available. So both can be utilized. In addition to that, we also run 7 numerical weather prediction models. And these models are utilized for assessing the current situation and also predicting up to 7 days. and we have got a seamless forecast system where we have the data up to forecast up to say season. Say for example, say this particular winter season or any beginning of the season we provide the forecast that is in spatial format in geospatial coordinate. And it is followed by the extended range forecast where every Thursday we issue the forecast that is again the geospatial format, and followed by the day-to-day forecast up to 7 to 10 days, and then every day we issue a forecast, and every 3 hours also we issue a forecast that is a very short range forecast called as the nowcast. So what I want to say that we are you can say Ratna Bhandar, just like you have got lot of data, and this data can be utilized in geospatial platform, and we are willing to provide the data, those industries, those startups and those researchers and academias who want to utilize our data and develop something for the national development. It can certainly help in improving the forecast, and if you can improve the forecast, you can improve the socio-economic development. I'll just give one example. So the natural disasters are responsible for loss of 5% of the GDP in the country. So if you can minimize the losses due to natural disasters, then you can save the 5% of the GDP. And by that way, you can improve the economic status of the country. I will take another example. For example, if you consider tropical cyclones, one tropical cyclones, one sector I will tell you, say for example, a power sector, one thermal plant is there, for example, in the path of tropical cyclones. So if we can give the correct forecast, and if the particular thermal plant can be given what is the hazard expected and vulnerability and risk to that particular plant, it can save 500 crore rupees. That has been proved. It has been proved by the independent assessment and also by the power sector. The POSOCO has brought out the report that it saves at least 500 crore rupees because of that. Yes. Similarly, if you just the common man like farmers, the information given to the farmers is helping a poor farmer who is having the income of say a below poverty farmer, below poverty line farmer, who is a marginal farmer with a agriculture area of less than 2 acres and who belongs to a rain-fed area where there is no irrigation facility. So if he or she utilizes the information, he saves 12,000 rupees per year, or he gains 12,000 rupees per year. We just compare the person who is utilizing weather information, the person who is not utilizing. So 12,000 rupees per year. Similarly, if you consider the monsoon, the 2002, for example, I will tell you, 2002 was a drought, and the drought in 2002 led to 8% loss in GDP. So you just imagine if you can predict well, and nowadays it is being predicted, but there are still scope to improve further with the intervention of this. We are giving, earlier we are giving only one forecast for country as a whole. Nowadays we are giving forecast for the seasonal rainfall distribution over different parts of the country, geospatial informations. But there are certain uncertainties. That uncertainties can be reduced by further improving the application of GIS and by comparing, analyzing the various informations and improving the forecast accuracy. So if that is done, you can just imagine if one good monsoon forecast, how it can save the economy. I'll just take an example last year. So when everybody was telling that it will be a failure of monsoon because of the El Nino, we told that no, it will be good monsoon condition, it will be normal monsoon condition, and finally it happened, and country was saved, and country got bumper crop yield. So this is the application where we can ensure the socio-economic development by minimizing the input cost of the farmers and fishermen and anyone, or industries also. And also we can maximize the optimum operation of all sectors utilizing weather and climate information geospatial technology. And finally, we can minimize the losses due to disasters, hydrometeorological disasters, with the geospatial technology blended with the weather and climate informations. So I thank you very much. I hope that today's deliberation will help us to check out the various plans and objectives to meet the target, that is geospatial applications for national development.